All right, today we're going to talk about molecular nomenclature, which is the naming for covalent compounds. And with naming, this is a series of rules that's put together by an overarching scientific body called IUPAC, which stands for the International Union of Pure and Applied Chemistry, and they come up with all the rules on such things. So molecular compounds are compounds that have covalent bonds in them, and covalent bonds, recall, are the sharing of valence electrons in order to, with the goal of fulfilling the octet rule. So we all want to have a full valence. We all want to look like noble gases. So we're going to share electrons to do that. And the things that are more prone to sharing electrons on the periodic table are nonmetals with other nonmetals. So if we think about our stair step of metalloids, then we know that 75% of the periodic table, everything to the left-hand side of those metalloids, are metals. So we're not talking about any of those. We're just staying on this side of the periodic table, just on the right-hand side of the periodic table. And we're ignoring the noble gases because the noble gases don't like to share either. Of course, there's exceptions to that, and you can get into that in other classes. But for our purposes today, we're just going to focus on the elements that are in between the metalloids and the noble gases. So this is a small little triangle of the periodic table, a fairly common and important biological element. So this includes all the different Schnapps kind of elements which are important to biological life. Schnapps, like the acronym for all of them, not like the liquor. Okay, so let's look at an example of why we need a naming system. If we have two compounds that look like this, so we have carbon monoxide, that's probably one you've heard of before, and hopefully one you have a detector for in your home, because carbon monoxide is incredibly deadly to humans. Carbon monoxide selectively replaces oxygen and causes suffocation, so that's bad. And carbon dioxide, which we hear a lot about with reference to atmospheric chemistry, and the carbon cycle, and carbon dioxide is an important greenhouse gas that is studied when looking at things like climate change, for example. So we have these two compounds. They're both made up of carbon and oxygen. So I can't just call this carbon oxide, because which one is which? Well, I have to tell you how many there are, and that's true with any of these combinations of nonmetals with other nonmetals. So you can see then that the difference between the two comes from the prefix. Here I have mono, here I have di. That is telling me the difference between the numbers of oxygens that I have in the compound. So these prefixes are very important. And kind of depending on the level of chemistry that you're studying, you might need to know different numbers. I'm going to give you the first 8. Those are the ones I like my students to know. So mono is 1, di is 2, tri is 3, tetra, like tetrapod, is 4, penta is 5, hexa is 6, hepta, is 7, and octa is 8. So penta through octa are pretty familiar, especially if you've taken any sort of like geometry kind of classes. So shapes with these different sides to them have these prefixes as well. Many of these prefixes are pretty common to the mono, di, tri. The only weird one is tetra, unless you've taken some biology, and tetrapodal organisms are one with 4 limbs. So that's kind of one way to remember that. All right, so here's the first 8. Those will get you through most of the common compounds that you're going to run into. And the way that it works in terms of rules is you need a prefix to tell you how many of the first element there are. So the prefix tells you the number. If it's more than 1, so you'll note in our carbon dioxide, I didn't call this monocarbon dioxide, I just called it carbon dioxide. So if it's more than 1, then I have to have a prefix, so di and above, to tell you how many of the first element there are. Then that's just the element name. So it's a nonmetal. I just want to know the element name. And again, no prefix required if there's 1, so just carbon. Then you're going to have the prefix that again tells you the number. And then that's even if it's 1, so in all cases. So like our carbon monoxide, even though there's only one oxygen, I'm still specifically saying monoxide. Again, there's exceptions to that too. If there's only one way that you can fit together particular elements, then they usually will drop the prefixes because it's just understood that there's just the one way. But for our purposes, again, today we'll focus on the prefixes as they apply. So we'll follow the rules. Now, the second part is a little bit trickier. It's not the full element name, it's the root of the element name. And so if you've studied any ionic naming, then this kind of looks like the naming of anions. So I take the root of the elemental name. So let's take chlorine, for example. Chlorine is a nonmetal, it's a halogen in column 17 or 7a. So the root for chlorine is chlor, and then I'd add an ending to that. And the ending in this case, as with anions, is -ide. So here's kind of your roadmap for naming these chemical compounds, these molecular compounds. So carbon, just the element name, no prefix required because there's one. Mono, meaning that there's one of those particular elements that we're going to talk about. Ox is the prefix or the root of our oxygen, and then it ends in -ide. Same with carbon dioxide. So let's do some practice here with some others. We'll kind of go from chemical formulas to names and names to chemical formulas. So if we take our PCl5 up here, P is phosphorus. Phosphorus, and then I don't have to have a prefix on it because there's only one of them, right? So there's no subscript, which indicates that it's a 1. And then the subscript here, 5, tells me that there's going to be penta for my prefix for the second. This is chlorine, just like we said. So our root is chlor, and then it ends in -ide. Phosphorus, pentachloride, which is one of my favorite chemical compounds. Now, if we look at the next one, this is a familiar chemical formula, but if we name it with IUPAC rules, then we would say, well, there's 2 of those hydrogens, dihydrogen, and there's 1 oxygen, and it's our second element, so monoxide, dihydrogen monoxide. You'll note that I dropped the vowel in mono, so I just traded that one out for ox. That's what you do in front of any elements that start with O or I. You usually will drop the vowel there. Of course, there's exceptions, and there's kind of different ways to say things, but when in doubt, you're going to drop the vowel in front of an element that has another vowel. Again, not always true. Diiodide comes to mind, which has 2 I's in it. Okay, so dihydrogen monoxide is one of those. This is of course water, right? The water is the common name. Water has been around for forever. You know, back when they thought that the world was only made up of 4 different elements, earth, air, fire, and water, they thought that water was elemental to everything. So water has been around as a concept for a very long time. But our naming rules would call it dihydrogen monoxide. One of my favorite things on the internet sometimes is every couple years, people are afraid of chemistry. They're afraid of chemical names. Chemicals are scary, right? So they'd say things like, oh, this lake is chock full of dihydrogen monoxide. You know, sign my petition that says we need to remove the dihydrogen monoxide from the lake. And then you just get thousands of signatures on it. Not dihydrogen monoxide, you know, so that's, it's good to know a little bit about chemistry, I think. Okay, let's go to the next one. So this is sulfur. There's 1 of them, so I don't need a prefix. For my fluorine here, there are 6, so 6 is hex. And then the root for fluorine is fluor. And then the ending on that is -ide. So all of these covalent compounds are going to end in -ide. When in doubt, chemical compounds are going to end in -ide. The only weirdness to that comes with ionic compounds when you have polyatomics that have their own name for those groups of elements that have charges on them. Okay, so there's some chemical names. Now let's go from a chemical name to a chemical formula. So we have dinitrogen tetroxide. I kind of like these because they just tell you everything that's in there. If you kind of know how to unpack them, Dinitrogen, there's 2 nitrogens. Tetroxide, this is oxygen, and there's 4 of them. So here's our chemical formula for that. Carbon disulfide, there's no prefix here, so that tells me there's 1. So carbon disulfide. So sulf comes from sulfur, di means that there's 2, and there's our chemical formula for that. So if you have any questions, as always, don't hesitate to reach out. Otherwise, I'll talk to you again soon.